Hello, people of Cantonian. I hope you're all safe in COVID land. This is week 8 for the lesson. We're going to do this lessons on the atom from some feedback we received from the previous lesson saying you found the atom quite difficult. Before we start, I just want to highlight some really good work that I thought was presented. I'm not going to say their name, but they'll know who they are. You can see that they're just writing along with the lesson. They're doing the do now activities. They're doing everything that pretty much you would be asked to do in a lesson. And this really is what we're looking for from this lesson. So there's no worksheet for this lesson. I'm just asking you to get some paper. Just get some blank paper and take a photo and then upload that. It's really, really easy. If you're finding troubles uploading pictures, then just drop one of us an email or Mr. Jackerman. And it's very, very simple to do. It's probably more simple than downloading the worksheet and then editing the worksheet and then re-uploading the worksheet. So I just think it's the way to go. Like I said, we're going to do the atom. Your keywords, proton, electron, neutron. Your do now activity is the same, and then your challenge there. Press pause. I'm going to do these and then we're going to come back. Lovely. Okay. So what type of variable do the investigators change? So from last week, we talked about how the investigator changed the independent variable, which is what I call the IV. It's just shorthand. Where on the graph would you find this? It's always on the bottom. Describe the relationship of this graph. Well, you can see as x increases, y is also getting bigger. So y increases, but it shoots up at first, but then it's decreasing then. So it's at a decreasing rate, okay? How are the elements in the periodic table arranged? Well, they're arranged by size and they're arranged by mass, okay? So they get heavier and bigger as you go along. And we'll look at that in this lesson. So here's your lesson objective for today. You're going to use the periodic table to analyze and draw the structures of a chosen element. So I'm going to give you an element, well, certain elements to draw, and you're going to draw these. But there's a way that we'd like these done and some information that you need to provide with them. Your keywords, we've talked about your proton, electron, neutron, and then this is not linked to Unit 7 GCSE, this is linked to chemistry. So first mistake by Mr. Timothy there, using the previous PowerPoint. Okay, so let's do a recap on the atomic structure. You should know this. It doesn't go into much depth. This is pretty much it. Once you learn it, it's kind of like learning the planets. Once you've learned the planets, it doesn't really go into any more depth. So we've got inside, so this structure here contains protons and neutrons. That's called your nucleus. So your nucleus pretty much contains your major mass. So we're not going to talk about mass so much because it's not in your spec. But a neutron and a proton has got a mass of 1. An electron is a tiny little thing. It's very, it's barely got a mass. It's like 1 over 2,000, something like that. So you've got this bulk in the middle, which is called your nucleus. Your protons are positive. Think like a proton. Remain positive. Your P and your positive, your proton is the link there. Neutrons are neutral. So there's that neut there. Neutron is neutral. And then by a process of elimination, your electron is the negative one. So you've got a positive, you've got a negative, and you've got a neutral. And you need to know this, okay? There's no other way you can learn it. I mean, you can watch some videos on it, but that is pretty much it. The exam question will probably be fill in one of these or tell me the charge on an electron, something like that. So just know it. How do you find elements in the periodic table? Because we're going to need to know this today. Well, we talk about groups and periods. A group essentially goes down. So if I'm talking, let's zoom in here. So if we're talking group 1 or group 2, group 1 elements are going to be found within this column. Okay. Group 2 elements are going to be found within this column. So group 2 elements could be beryllium, magnesium, calcium, strontium. He said strontium there. What about a group 7 element? Well, let's have a look at group 7. Now we miss this bulk here. All this bulk we don't need to worry about. That's for A-level students. Don't worry about them. Just worry about yourself now. But we're going to go 1, 2, right the way over to 3, 4, 5, 6, and 7. So your group 7 elements, you got fluorine, you got chlorine, you got bromine, you got iodine, all ending in "ine", okay? Your group 5 elements, your group 4. So hopefully you can see now that a group goes down, okay? Period goes across. So periods are here. See here, period 1, period 2, period 3. So if I want any period 3 element, I can have sodium, I can have magnesium. Oh, I've got nothing there now. Let's move across. Oh, I can also have aluminium. I can have silicon, because they're 3 rows down. It's in period 3, okay? Some misconceptions here is that we tend to miss, especially when it's not labeled on the periodic table, we tend to miss group 1, which is hydrogen and helium. It's easy to make the mistake for group 1, just saying lithium and beryllium, okay? Sorry, not group 1, period 1. It's easy to make that mistake. So the period starts from hydrogen because it's linked with shells, and I'll show you the shells now. If you remember how to draw electron shells, it's 2 in the first one and then 8. Well, if you look at the periodic table, in the first shell, you can get 2 electrons, 1, 2. And then in the second shell is 1, 2, 3, 4, 5, 6, 7, 8. And in the third shell, you've got 1, 2, 3, 4, 5, 6, 7, 8. So when we talk about electrons in shells, it is very much linked to the periodic table. So let's just keep that in mind. So let's have a bit of a practice here. I want to find the element that's in group 2, period 4. Well, what would I do? I would look to group 2. So groups, they go down. So this is group 2. Let me just zoom in there so you can see group 2. Okay. Period 4. Well, here's my period 4. Actually, I'll do these in another color. Group 2, period 4. So it's almost like a bit of a battleships thing going on now, where you can identify your element from your coordinates. I've got group 2, period 4, which is calcium. So that is Ca. Maybe try this one yourself. Group 3, period 3. Well, let's play along anyway. Group 3 is all the way over here. Groups go down. So you group 3, period 3. Now it would be easy to count 1, 2, 3. But remember, you've got helium, this group up here. So it is actually 1, 2, 3. If you look over here, group 3 comes across from there. So group 3 would be aluminium. Group 3, period 3, Al. Have a go yourself. Test yourself, press pause, and we'll see if you get it right. So group 2, period 3 is going to be magnesium, Mg. Hopefully you're getting this. If you're not, please drop a comment or a message, and we can look at this together in a bit more depth. So the next step then is to interpret the periodic table. What do these, so we kind of know what the symbols stand for. It's the symbol of the element, not always the starting letter of the element, such as sodium, Na. You'd think it start with S, but let's not even get into that. And then we've got these numbers. We've got big numbers and small numbers. I like to say big numbers and small numbers and not top numbers and bottom numbers, because sometimes the big number, depending on which periodic table you use, is on the bottom of the element and the small number is on the top. So we talk big and small numbers. So the big number is going to tell us the mass number. Okay? And the small number is going to tell us the atomic number. What's the difference, I hear you ask? Well, the mass number is the number of protons plus neutrons, and that's very important. This plus is very, very important. The atomic number tells you the number of protons, or, and there's an or there, electrons. Remember from our first diagram, protons are positive, electrons are negative. All atoms should be equally charged. Therefore, for every positive, you need a negative. So if you've got 8 protons, or in this case, if you've got 5 protons, in this case, boron has 5 protons, it should have 5 electrons. And that is the number we're going to be using in this lesson, because now we know that boron has got 5 electrons. Therefore, I can do my electron shell. The number of protons and neutrons, to find the number of protons is easy because you can just use your 5. But how do you find the number of neutrons? Well, slightly more difficult, but not really that difficult. Let's use another color here. If I've got 11 protons plus neutrons, and I know that I've got 5 protons, then surely it's 11 minus 5 gives me 6. So now I've got 6 neutrons there. Okay, you might want to re-watch that. I'm not going to go through it again like I would do in a lesson, because you've got the ability to rewind. Let's have a look at oxygen. So the way that we'd really like you to write this is pen. Protons for P, electrons, neutrons. So how many protons has oxygen got? Well, we'll look at the atomic number, the small number. It's got 8. If it's got 8 protons, which are positive, we need 8 electrons. That's easy. So far, so good. And then we've got to work out our neutrons. Now, 16 minus 8 isn't a difficult sum. We know that's 8, hopefully. All right? And that is literally what we do. It's not difficult. If you're listening, you'll learn. Phosphorus. Let's do the pen method. My year 7s, I know you would have done this. Year 8s, maybe. Year 10s, you might have forgotten all this. So it's a really good recap. Pen. My small number, 15. My small number, 15. They're the same. My neutrons now, 31 minus 15. Ooh, I might have to get a calculator for this. I think it's 16. If I'm wrong, please comment. Are we happy with this? I hope so, because you're going to have some practice now. So, test yourself, press pause. Bit of a tricky one, because it says find the number of protons, electrons, and neutrons. So we want pen, like I've just done, for the element that is found in group 3, period 3. So you're going to have to find that element and give me the number of electrons, protons, and neutrons. Off you go. So if you've identified correctly, you would have identified aluminium as being in group 3 and then period 3. So aluminium is your boy. It's got 13 as the small number and 27 as the large number. So your number of protons, 13, electrons, 13, neutrons, 27 minus 13 is 14. And you can see there's a bit of the number of neutrons is either going to be equal to or slightly more, unless you get to the really heavy elements, the radioactive ones. It's either going to be equal to or slightly more than the number of protons and electrons. So if you're getting something along the lines of 20 or 21 compared to 13 and 13, you know that you've done your calculation wrong. So just always check. So we've done the structure of an atom. We know how to find them in the periodic table. We know what these numbers mean. So I guess the last thing now for us to do is to draw the structure of an atom or the electronic structure of an atom with all of the information we know. So I'm going to start showing you how we'd like this presented on the paper. So it says draw a dot and cross diagram for electron structure for carbon. So first things first, I'm going to write down my pen. So pen, because I want to know how many electrons there are. So I've got 6 is my small number, 6 protons, 6 electrons, and I've got 12 minus 6, which is 6 neutrons. Now, the biggest mistake students make is that they use this, let me do this in blue, they use this to draw their electron configuration, and it's not that, you're not drawing the number of neutrons, you're drawing the number of electrons. So this is the one that you need, okay? I'm going to highlight now in green, let's use the nice green, we're going to use the number of electrons. Now it's just coincidence in this case that the number of electrons is equal to the number of neutrons, so you couldn't get it wrong on this one, but you could on future ones, and I'll show you now. So let me move back to my red pen. So we don't have to draw the nucleus, we've only got to put a little dot, just like this. Now we're going to draw our first shell, which is a circle. Now you can see it's not a perfect circle, but it doesn't need to be. Now in the first shell, we can hold two electrons. You can think of this now as the first shell being a bit of a hotel for little electrons who need to stop somewhere to have a rest. Okay, they need a bed for the night. Where can they stop? Well, I've got 6 electrons to look after. I need to look after 6 electrons. The only trouble, my hotel can only fit 2 electrons in the first shell, in the first floor. So I've only got 2 bedrooms. So I've got 1 electron and I've got 2 electrons taking their place. So I've still got to find rooms for another 4 electrons. And this again links with the periodic table. Can you see that we looked at, there was only 2 in the first period. So you can essentially think of these shells now being periods. Okay, let's go back down. So I've got 2 electrons in the first shell. I need another shell. So I'm going to do another shell there. Okay, so it's a bigger circle around the last one, and I've got 4 electrons to get rid of. Well, I can fit now. I've got 8 rooms in my second shell, so I can fit up to 8 electrons. Well, I'm sorted because I've only got 4 left to room. And the way we're going to do this, we're going to go 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. And there's a reason why we do that, because when we start doubling up, you need to show the examiner clarity. Okay, if you've got X's everywhere and they can't read it, even though you might be right, you're not going to get the mark. So you need some clarity there, and we're going to spread them out. Now, how many electrons have I got in total? 1, 2 in my first shell. 1, 2, 3, 4. 4 plus 2 is 6. And that's how we're going to write the electron configuration. I've got 2, 4. And that is my electron configuration for carbon. Okay, happy with that? I'm going to do some more practice. Let's do oxygen. So oxygen here has got a small number of 8, large number of 16. So let's get my pen down. So this is how I like to do it. Pen. Well, I've got, is this still recording? Yeah. So I've got 8 protons. I've got 8 electrons, therefore, and I've got 16 minus 8, which is 8 neutrons. I want the number of electrons. Okay, so I'm going to zoom in slightly here. I'm going to draw my little nucleus. Doesn't matter, we don't have to represent neutrons or protons. And then I'm going to do my first shell. It can only hold 2. I've got 8 to get rid of. So I'm going to go 1, 2. Notice how I'm doing them at 12 o'clock and 6 o'clock as well. Nice and neat. Okay, you just don't want to lump these together. I need another shell now because I've got an extra 6 electrons to get rid of. So I'm going to go 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. I need to go 12 o'clock again. So I'm just going to put that X right next to him, and I'm going to put this one right next to him. So now I've got 1, 2 in my inner shell, 3, 4, 5, 6, 7, 8. 8 electrons in total. I've got my shell. My first shell holds 2, and then my second shell holds 6. So my EC for this one is 2, 6. Let's do another one together. Hydrogen, the easiest one. Protons, electrons, neutrons. I've got a small number of 1. I've got a small number of 1 there. So I've got 1 proton, 1 electron. How many neutrons have I got? Well, I've got a big number of 1, a small number of 1. That's right. There are no neutrons for hydrogen. It's such a light element. It's the smallest element. So if you were to use the number of neutrons to do the electron configuration, you wouldn't have an electron configuration. But it's a good job. We're going to use the electron configuration. So I've got 1 shell. I've got 1 little electron. He says, I need a room. Can you put me up? Yep, there you are. Have a bed for the night. Poor little electron. And that is it. I mean, you would just put EC equals 1 there. It's unlikely to come up, but I thought I'd do it. And then you've got this massive argon then. So you've got protons, electrons, neutrons. So I've got 18 protons, I've got 18 electrons, I've got 40 minus 18, which is going to be 22. Yeah. 22 neutrons. I'm looking for the electron number. So this time I got 1, 2 in my first shell. Can't hold any more. I've got 18 to put up for the night, so I need another shell. I'm going to go 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. I can do that again because the next shell can hold up to 8. So I'm going to go 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. I need to do another shell now because I've managed to get rid of 2 plus 8. So I've managed to get rid of 10 electrons, but I need to get rid of another 8 electrons. So I need another shell. My next shell can hold another 8. 1, 2, 3, 4, 5, 6, 7, 8. And now in total that is 18. So I've got 8 plus 8 plus 2, which is 18. It's not going to get any bigger than this. So my electron configuration equals 2, 8, 8. And that's probably the biggest you will be asked to do. You're not going to be asked to do another shell because then we kind of get into A-level territory. I hope that's okay. Like I said, any questions on this, anything that I've missed, drop a comment or an email. So here's your quick quiz before we push on, and then we'll get on to the meat and potatoes of it all. So press pause, complete this quick quiz, and then we'll come to the assignment. And welcome back. So name 3 subatomic particles found in the atom. Hopefully you recognize that to be protons, electrons, and neutrons. The term subatomic particles is a term that they'll use to try and sideline you, but hopefully you can link this back. So subatomic just means you've got the atom, and then that atom is made up of smaller parts, So your subatomic particles, protons, electrons, neutrons. Which are positive? Hopefully you know, they're protons. What does the small number next to any element of the periodic represent? It's the atomic number, which represents the number of protons, or in our case today, electrons, because it's the same number of protons as electrons. How can you use the atomic number and mass number to calculate the number of neutrons? Well, it's mass number, which is the big number, minus the atomic number, which is the small number, and that's going to give you your number of neutrons. We've been doing that. How many electrons can fit in the first shell? 2. Lovely. And so now we're going to look at the assignment, and there's 2 ways. Well, there's 2 ways you can use this video. You can either do it step by step with me as I flick through them, or you can go to the end of the video and I've got the list of questions there. So I've said complete on a piece of paper, just like this one, okay? So you don't need to submit the rest of the lesson. It's nice if you do. If you've done the work with me, you can. But this is the bit now. What follows is what needs to be submitted to get your mark. So complete on a piece of paper and photograph it and upload it. Use the layout that I've shown you. So you can even write the group and period number of the elements that I'm giving you. I definitely want the pen, protons, electrons, neutrons. I want that electron configuration, which is either like 2 comma something, and also the diagram, which is the dot and cross diagram. So you put your nucleus in the middle, and then you draw your shells with the X's to represent electrons. There's 6 questions with 2 challenge questions. So each is going to be shown with a periodic table, because we understand that you might not have a periodic table at home. But if you do have a periodic table, you can find the questions right at the end. So it saves you watching the trawling through the video then. I'm going to do the first one with you just to show you of what expected. But I've kind of shown you anyway. So your question 1 is there magnesium. So I'm going to find, my first challenge really is to find magnesium in the periodic table, so I can see it right there. So magnesium, I know, is in group to period 3. We've done this example before, I'm sure. What's my pen for it? So I should really give myself some room here. So I'm just gonna do this at the bottom here. So group to period 3. I've got a pen of, well, what's the small number for magnesium? It's 12. My electrons are 12, therefore my neutrons are 24 minus 12 equals 12. Again, I'm getting all this from there. There's my 24, there's my 12. Then I'm going to do the electron configuration. I'm going to draw it first. So I'm going to try and do this now because this is quite a big one. So I'm going to do one shell there, 12 o'clock, 6 o'clock. I'm going to do my next shell. I've got 12 electrons again in. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 10 there. I need another 2. So I'm going to do another shell. I'm going to go 12 o'clock, 6 o'clock there. And that really shows the examiner clarity because they can see that these electrons are paired there. So they can see quite easily there's 2 in the first one, 8 in the second one, which is 10, and then an extra 2, which is 12. My electron configuration for this would be 2, 8, 2, EC. Okay, good luck. Enjoy the challenge questions, and we'll see you in a future video. Oh, by the way, we're going to do some sort of I don't know, what are these YouTube channels called? For so many thumbs up, we'll give you a treat. So if we get 30 likes for this video, I will show you a tiny little bit of my Lego room where I keep my Lego, okay? And that'd be a real treat for you guys. All right, have fun.